Hello, my name is Nigel Ward. This is Devet. Thank you for coming to our presentation. We'll be talking about pragmatic similarity and describing the database, the corpus that we created. This is for the LREC conference 2024. So right off, let me start by talking about pragmatics. So human spoken language, it has the words and the prosody. It has the meaning, the literal meaning and the social meaning. It has the semantic content and the pragmatic intent. Most work coming from sort of the textual perspective or the sort of Alexa perspective where everything is about the content, not the feeling, not the interaction, has focused on the left side. But our focus is on the pragmatic intent. What are people trying to do? Not just what the words literally mean, but are they angry, upset, trying to praise somebody, trying to persuade somebody, trying to apologize, trying to elicit empathy, those aspects of language. These things get important when you're building dialogue systems that are just not passive, but they're actually active, they're cooperative, they're engaging. Let's make that concrete. Let's talk about speech synthesis. So speech synthesis today is already really highly intelligible. I'll give you a clip to illustrate that.
AI voices are paragons of intelligibility.
Right, AI voices are paragons of intelligibility. They really do sound very nice. Listen to that again. You'll hear every phoneme is perfectly clear.
AI voices are paragons of intelligibility.
Yeah, I don't think my voice is that clear. But humans have their advantages. Humans can be very expressive. So, for example...
That one's so good. I love that one.
Okay. And then the AI version.
That one's so good. I love that one.
Okay, something's lacking. A lot's lacking, right? So one of the reasons for this is because of the way that synthesizers are built today. So synthesizers convert a sequence of words into a speech signal. Usually they are trained to minimize a certain distance. So if in the training data you have a pairing of word sequences and speech signals, you can feed the words to the synthesizer, it produces some output, and then you can compare that to the actual audio produced by the human. If there's a perfect match, you're done. If there's a discrepancy, then you compute the loss or the error or the difference and feed that back to the synthesizer using backpropagation. So it's critical that this loss function accurately measures the distance between the target and what the system produces. And those loss functions today are based on semantic similarity, getting like the words and the meaning right, or various crude prosody measures. Or they use human judgments. Human judgments are not really effective for scaling up, for in-the-loop training, and human judgments are, of course, very expensive to obtain. So that's our motivation. We want to build a better loss function, a better measure of the similarity between two speech clips. So just to put those things in a list, for speech synthesis, we have an application. For second language training also. Imagine somebody wants to learn how to say yes in English in different contexts. Right? So in different situations, you want to have different pragmatic force on your yes. And I can illustrate some of that.
Mine was cooking popcorn, right? Is that what we said?
Yes.
Yes, he's confident. Maybe a little bit annoyed, but he's confident and engaged.
Blanket or rug?
Yeah.
Okay. And
Yeah, he's somewhat distressed here. He doesn't really want to be part of the conversation, and he's not even sure that what she's saying is correct.
is the person wearing a blue shirt?
Yes.
Yes. All right. So most of the models we deal with today, training, evaluation, whatever, assume that these are all the same. A yes is a yes is a yes. But we need to make those distinctions. When are they pretty similar? When are they far apart? And for other purposes also. All right. So what we need is a model of pragmatic similarity. Related work mentioned briefly, models of semantic similarity, prosodic similarity. For pragmatic similarity, there's some work by Pragst a couple years ago where she considered two utterances to be pragmatically identical if they express the same speech act, such as persuade somebody to exercise more or scold somebody for eating too much. And so it's either match or not match, which is not really adequate for nuanced evaluation or complex multifaceted utterances. So to recap, pragmatic similarity is what we're interested in. We're interested in spoken dialogue, and to build models of pragmatic similarity, we need data. We need training data or evaluation data. Data doesn't exist, so we collected some, and that's the topic of this talk. So I've talked about the need, we'll talk about the data, some lessons we learned in the data collection, and then we'll present a model. So long story short, the data is done. It's available. You can go to the vet's GitHub page and download it. This consists of utterance pairs, dialogue style utterance pairs, played together, and when we have human judgments of how similar they are, the vet will give you all the details. But it's a large data set, the agreement is often pretty good, and you can download it and use it. But here's the vet with all the details.
Okay. Hi, my name is. Okay. Hi, my name is Devet Marco, and I'm gonna be talking about the data collection process. So basically, I'm gonna ask you all to be participants right now. So I'm gonna ask you a question: how pragmatically similar are these in terms of overall feeling, tone, and intent? So I'm gonna play a clip, and I want you all to give a raise of fingers, rated on a scale of 1 to 5. How pragmatically similar are these? So you're gonna hear two clips separated by a beep. So let me play one.
But recently I got into jiu-jitsu.
But recently I got into jiu-jitsu.
Okay. So I see some ratings. I'm gonna play it one more time for you.
But recently I got into jiu-jitsu.
But recently I got into jiu-jitsu.
Okay. So I see a couple 4s, 5s. Okay. So I'm gonna give another example.
I don't know, it was like really annoying.
Not to be mean, but it was really annoying.
Okay, can I see your ratings? Okay, I see some 4s, some 5s. One more example.
But I'm looking forward to impressing him, like giving him a fun show.
We can definitely help you with that.
Okay, some 2s, some 3s. So basically this was the process we did for hundreds of stimuli. We did this with a group of judges. So this was a group of students that had previously worked on other data collections. They were really fun to work with. They showed like sensitivity to language. For these sessions, they were all 4 hours long. We had lunch together. We also paid them $70. But it was a really interesting session where we learned throughout all 3 of them. Okay, so the design choices. So we are using dialogue data. We were using a rating system versus a ranking or an ABX system. We used a continuous rating of 1 to 5. We used this instead of discrete because we wanted more information from the data we collected. When we presented the audio clips that were being compared, we wanted minimal delay between the presentation, so we were only separating it with a beep. This is because auditory trace disappears quickly, and we wanted to give the participants a good stimuli. We also presented it context-free, so that way it would be more efficient. So we already went over the question we asked the participants, but in order for them to understand what we were really looking for, we had training sessions and discussion sessions. We really tried to drill in the idea that we're focusing on the pragmatics. So we told them to ignore speaker differences, differences in semantics, differences in the way they talk, just pitch, rating, pausing, rate, pausing, etc. Yeah. Okay. So the stimulus creation. So each pair, we would choose a clip from a real dialogue, and we would create reenactments for that clip. And we had a bunch of conditions that we created the reenactments. So then that way we would get different types of clips. So some they were very similar, some were moderately similar. We tried to create this variety, so that way it would be better for our training, better data for the training. We also did the speech synthesizer. That one was just text put into the speech synthesizer. Those clips were the ones that were the least similar. Okay, so factors affecting ratings. So we found that judges themselves varied. So if you could see on the box plots, the y-axis is the participants, and then the x-axis is the rating. So some of the judges used a larger range. Some judges were more generous with the ratings. Overall, we saw that judges got more generous, slightly more generous over time. We also saw that throughout the sessions, as the judges got more experienced, they learned to use more of the scale, and they became faster with their judgments. So factors affecting agreement. So we found the inter-judge agreement between the different pairings of the judges. The highest we got was 0.8 between participant 4 and 8. We also got some judges that got lower inter-judge agreements. There was one judge in particular, Judge 9, that got a low agreement rate with everyone. It was 0.29. This was a participant that didn't come back for later sessions. So we think that's one of the reasons why the inter-judge agreement went from 0.48 in the first session to 0.72 in the second session. So this was really good, an improvement that we were pretty proud of. So then some other factors affecting agreement. So right now I'm going to show you a clip that I'm going to play, and I'm going to ask you all to rate it, and we're going to discuss why we think, or I'm going to discuss why we think this clip had low agreement among the judges. So here we go.
What happened today? You saw her?
So, and why? Do you see her today?
Okay. I see some 4s, some 2s, some 5s. Okay. So this was one stimuli that the judges disagreed on. We think this is because the female voice had more emotion, more feeling. She used ingressive fillers, breathiness, versus the male speaker who lacked a bunch of these qualities. In general, we found that there was better agreements for blandly spoken pairs, and also for pairs where there were similar personality speakers. There were also some more factors that affected agreements, but we discussed those in the paper. You can check that out. And now I'm going to pass it off to Dr. Wood, who is going to continue with a bonus topic.
Thanks, Devet. Right. So we actually use this data to build a model. The input is 2 audio clips. The output is a similarity estimate. So it does just what the humans did. It gave us an estimate between 1 and 5 of the similarity. Internally, that's a different paper, but we used Hubert features, down-selected. The performance is pretty good. Compared to the worst human, it's sort of in the range, and it's not terribly far below the average human. And considering that these are very well-trained, well-paid, well-fed humans, we think it would probably outperform the average mechanical Turk human judge, for example. As an illustration, we built a little demonstration that will listen in a conversation, pull out audio clips, and then find in a reference data set of over 5,000 switchboard utterances the most similar. So this is a way to see if it really is good at detecting similarity. So I'll play you a clip.
I drive a Hyundai Elantra. It's a gray color. I chose it.
And something supposedly similar.
I use 123 a lot, the Lotus product, as a spreadsheet, and I use a...
All right, so I think you can hear some similarity. Different dialect, different age, different gender, but they're both talking about a product choice. It's both early in the conversation. They're both a little hesitant. They're both feeling positive about the product that they use, and they're about to give the reasons. Lots of dimensions of similarity here. And we often see this. It doesn't always work, but when it does, it can be quite interesting. All right, and you can see in YouTube the Pragmatic-Similarity demo that shows the whole story. To sum up, our contributions are a protocol, observations of some factors affecting ratings and agreement, and the set of data, the set of the judgments that you can use for whatever purpose. Please download it and enjoy.